Um, hello, hello. Am I live or not? Started. Just writing down. Hello. Just let me know quickly. Just let me know if I'm live or not. Oh God, this Mac is insane. Can we please just have a refresh? Just let me know if we are live or not. Like whosoever is here. Still the things are not set up. My tablet is not connected, but at least we are live. Hello, hi Yash. Hi Yash. Hi. Like apologies a lot because of this. I tried to restart it 3 times. Restart did not work. Shutdown worked, and that too. Hi Krishna, hi, good morning. It is great to see you guys. Let me quickly just set up and get things done, because I was just trying to get live and it was not even coming live. And it's an issue with MacBook that it doesn't understand things. Like no matter what you try, it will not understand things. It's the worst thing ever. Although, just to have a heads up, we will see every question 1, 2, 3, 4. In fourth question, you will see a lot of solutions which are wrong, because question 4 for C++, there was actually some cases were not correct, so it's a reason for many people it passed. For question 4, you will see around 400 plus solution, but still these are incorrect solutions, and when the test cases are updated, they won't pass. So we will see the best solution possible. But before that, please let us connect our tablet, because everything got messed up because of this thing. I don't know why my OBS keeps on crashing. Yeah, that was so painful. Now you can see I'm just trying to connect. Oh, it worked. That's I think that MacBooks are reliable, but now I don't believe them at all. Now, cool, we'll quickly start off. We'll have some comments. Yeah, firstly, write down that how many questions you guys did and how much time, and then any other questions, doubts, whatsoever you guys have, we can take that on also. Before that, we have some folks watching. Can we please smash that like baby to 10 likes? Just one more, that would be super great. Cool. Everything is fine. Audio, video, everything is okay. I hope the streaming is not lagging. Everything is good, fine, because my OBS kept on crashing continuously and I was painful. Like, we postponed it from 11 to 12 and then from still 12 to like 12:14. Cool. Like, I think everything is fine now. Everything looks okay. Let's start off. Firstly, let's have a quick comments. Just write down that how many questions you guys did and how much time, and also that what you thought of question number, like for the ones you could not solve, what you at least thought of that. Cool. Hi bro, good morning. Hi Krishna, hi Pranay, you are live. Chalo start kar bhai. Bilkul. Akansh, Akshansh. Okay. Hi Aditya, hi Atishay, hello Yash, hello Om Kumar, hello भैया, hello M श्रीकांत. भैया मैं भी अभी DSL रन कर रहा हूँ एंड साथ ही लीडकोड कॉन्टेस्ट भी दे रहा हूँ, तो अभी कॉन्टेस्ट होते हैं उसके थर्ड फोर्थ क्वेश्चन मुझे देखना चाहिए, क्योंकि वो टॉपिक में आगे करूंगा. See, I'll recommend that, like, it's good to actually see things so that to get familiar with it. Meanwhile, there can be high chance you won't understand it much, but still I highly recommend just watch it down, because it will be very helpful for you in future. That's the reason I just recommend it. Cool. We'll start off with the first. We'll go on to the comments, go on to very deep also, but let's start off with the problems itself. Let me quickly find. So first question is, we have 30 folks watching in. We'll be starting now because it has been already 14 minutes late. Matrix similarity after cyclic shifts. Now you are having a zero indexed M cross N matrix. Let's go to the editor itself, which we have. And yeah, if the folks are watching and the folks are regular, if the regular folks are watching in, can we please smash that like baby? Yaar, you guys are regular, we are regular. ऐसा लाइक नहीं बनेगा तो कैसे बनेगा? Cool. Let's see. So it just says that matrix similarity after cyclic shifts. Now, whensoever you should have read the cyclic shift word, you should have for sure must have thought of that you would never do. Again, I have not even read the question. I have not even thought of what it asked. It's just that even after just reading this word cyclic shift, it should come to my mind is that I must be doing something of, okay, if I am at the index I want to do a cyclic shift and something I want to know its location, so I will be doing, okay, just do X number of cyclic shift, but then you should have a limitation of what is the length of your like the thing which you have, which is the array itself, so which is the length of the array. So that is one thing which you must make sure. I'll quickly have in parallel the chats and stuff. Let me quickly have everything in parallel. How to do it? Cool. We will have it on phone itself, no worries. Cool. Now what ultimately, like, see, now just that we just have thought of this, that okay, if we are asked to do X cyclic shifts, then we can do something like this. And again, I have not even read the question. Cool. Now let's read the question. You are given a 0 indexed M cross n integer matrix. Okay, I have a matrix, great, and an integer k. Okay, that is also great. We have an integer k also. Now integer k we have, that is good. Now you have to cyclically right shift odd indexed rows. Now for sure indexing is 0 based, so it is a 0, 1 and 2. Indexing is 0 based, so I have to cyclic right shift odd indexed rows k times and cyclic right left shift even indexed rows k times. Now when I say right shift, I actually mean that if I have an element right here, it will go here, right? That is the right shift. Now when I say left shift, I actually mean that when I have an element here, it will come here. That is what left shift means. So for the odd indexed, we will do a right shift. For the even index, we will do a left shift. That is the question says. Cool. Now simply going on, return true if the initial and the final matrix are exactly the same, and else return false. So ultimately I'll do a right shift, I'll do a left shift. So I'm saying that the matrix should remain same, which means if, let's say, I just take any random row, odd row. If my elements are A, B, and let's say here it is a C and a D. If I do a right shift, so this B will go here, right? Which means here already it should have been a B. It should have been a B because ultimately it is the original array. Right? If I do a right shift, it would look something like this. The B will shift here, the next B will shift here, the D will shift here, and the A will shift here. So just to make sure that on right shift the things remain same, you will say that okay, B and B should have been same. This B and this B should have been same. Okay, which means that on a right shift of that specific, and when I say this B, I mean this B at the index, let's say 2, and this is a B which was the original B which was at the index 1, because I am saying I'll right shift just one time ultimately. Okay, so with this what we can infer is that and as you saw that to right shift I can just do something like this. So I'll just make sure, okay, if this is my row, so I'll just say row of my I, index I. Let's say my index I is here, right? I'll say it should be equal to row of I plus, if I do a right shift, by k times, and then for sure right shift, so it should cyclically go and come back to some location, mod of n, it should be equal. That is for sure a right shift operation. Now what shall I do for left shift? Shall I do something else for left shift? As in, one thing you can do is I minus of that specific k, then plus n, and then mod n. This is something you can do for left shift, but let's see if it is actually required or not. If I'm saying you will do a left shift, what will happen? This thing will come here, right? So if there would have been a B, it needs to have a B right here. So if I just write the same stuff again, or let's write another thing, let's write the same thing. So it would have become a B would have come here, B would have come here, A would have come here, D would have come here. So you would see that it should match. This is at index 2, at index 1, it was at index 2. So again, the same stuff, that these should have been same. So no matter what, if I do a right shift or a left shift, it is just indirectly saying that these should be same. These elements, if I am landing onto some index, it should have been same. So what I'll simply do is I can simply go and check for the row. Again, it won't matter even or odd row. Ultimately, if you can still do one thing, okay, from left right I can go on in the odd rows, and from right left I can go on in the even rows. But still, even if you just apply a simple condition, like it's just simplifying in just one pass, that if I can just make sure that my row of I is actually equal to row of I plus k mod n, then it will actually go and check if that specific element is actually equal to, if I just do a modulo and go to some other element and find the answer for that. And with this you can simply get and solve the answer. I used a DQ, I think was the best DSF for this problem. Yeah, DQ you can use for sure, it's good. You can just, because constraints are pretty small, and you can just left shift k times in a DQ, and that can actually work for sure, because in DQ you can just shift, push back from the left, any operations you can do. But the fact is that this cyclic shift operation, okay, in this case you use a DQ, that's good because the constraints are pretty small. But when I ask you to find, let's say if this k would have been very large, let's say the k is small, let's say if I would have asked you, bro, the k is very large, k is actually 1e9, then if you try shifting 1e9 times, then your entire thing is gone. So it's good to know this trick of shifting and any element by some positions, which is k positions. So its new location will be nothing but I plus that k shifts mod n, and that is very standard. Let's quickly code this up. If you know or don't, I was making that today's problems video, so I was not able to actually solve the live contest. So yeah, I'll code with you guys. You will see that if we have some issues or not. Cool. Now, as we saw that we just want to know if at any point of time we actually have got the true as false. So ultimately in the end we should return a true. If at any point of time, if my condition becomes false, I'll return a false. Now I'll just get the n and m. I'll just find the end, okay, n and m, and mat of 0 dot size. Now with this fact, I can just simply go on to all of my rows, right? Now as I go into all of my rows, now I will just go and have a check on every row. Now I just have a quick check on this row, so I should go on to, let's say, j equal to 0, j is less than m, and j plus plus. So I'm going to every column, and I can just have a quick check that if my mat of I and j, if this is not equals to mat of I, and you saw that I'll do a right shift of that index j by k times, I'll do a j plus k mod of the size of this particular thing, which is actually of size n rows and m columns. So I'll do a m mod m. If this is not same, sorry bro, that is a false, so simply return a false, and thus we can simply return a true. Let's quickly see if we have not done any blunders. True, false. Let's quickly submit and see. Yeah, that's good. Cool. We'll quickly go on to question number 2. And yeah, question number 2 follow-up is actually question number 4. We'll go on to question number 4 also, but let's quickly have a chat read, and then meanwhile, if the folks are watching, can you please smash that like baby to 25 likes, just 3 more, that would be super great. Bhaiya मैं अभी DSA start, see, like Om Kumar I just had said that it's good, continue that DSA. Still, if you have just started, still try to solve question 3 and 4, because like let's say for today's contest, question 3 was a bit more medium, like it was a medium to medium plus question, so it's good that. But sometimes it happens that still question 4 is actually a medium level problem, not a medium. So basically I classify medium as medium minus, medium, or medium plus. So today's question, question number 2 was simple, a medium minus, and question number 3 was a medium plus. Sometimes a medium question also comes in. So yeah, Adarsh 1, no worries. Ajay Kumar, no worries 1. Kunal 2/4 in 30 minutes. Okay. First question was a bit tricky, I should say. Yeah. Suhardya. Sure. Okay, like I'm very bad at names. Sorry. 2. Krishna Bro, I solved the first 3 in 1 hour with 3 wrong submissions. Krishna, if you even saw, like, if you saw the 3, that's great. First, that's an achievement. But 3 wrong submissions, we can improve on the submissions. Okay. Atishay, only 2 questions. No worries. I got TLE in first two. TLE. Okay. Akshansh. Ritik, third was hard for me. Yeah, third was actually not standard, but we can just think of, like, if you have been watching our array playlist or array intuition building playlist, or basically like live streams previously, so we have seen question third kind of similar problems also. We'll see. 3 questions, 30 minutes. That great, Princey. 0 questions done. No worries, Mercy. It's just for us to learn. 29 plus contest done. Still not able to solve the third one. Atishay, yeah, see, when you will see the problem, you will figure out that it was actually intuitional. It will be the way how we think of. Cool. Let's quickly go and start off with the question number 2. So we'll go on to question number 2. Now the question 2 says that count the beautiful substrings 1. Now you are given a string s and a positive integer k. S and a positive integer k. Now vowels and consonants be the number of vowels and consonants in a strings. It's just that we know what are vowels. It's just that we know what are consonants. So vowels is just that if it's a A, I, O, U, it's a vowel. Consonant is if it's just not a vowel, it's a consonant. Now count of vowel should be equal to count of consonants. That is one thing. And also the count of their multiplication. Again, that's a count of their multiplication mod k's value which is given to you should be actually 0. Now I have to go and return the number of non-empty beautiful substrings. Again, it should be non-empty, and it should be beautiful substring, which means it should satisfy both these conditions. And in the given string s, and it just shows what is a substring, it just shows what's a vowel, and it just shows what's a consonant. So we just want all the substrings. First thing comes in the mind is, can we generate all the substrings and meanwhile find the answer? For sure we can. Now, one way which comes in people's mind is that we can generate all the n square substrings, and then we can check for that specific substring if that is actual satisfying, which is actually beautiful or not, which can be O of nq, which will not work. But we can just modify the same thing as we have seen earlier also, that while generating the substrings itself, I will keep on computing for that specific substring while generating the substrings itself, which means if I have a string as B, A, E, Y, H, so I'll start my I here. Now my J will be also here initially. So I am now generating the substrings, and while generating itself, I will make sure that I am counting my consonants and vowel count. So here my J is here, my consonant count is 1. Okay. And again, my consonant count is 1. Keep on checking this condition also parallelly. My J moves, my vowel count has become 1. Cool. Now you saw the K is 2. Now 1 into 1 mod 2, that is not true. So you just you just moved ahead. Again, vowel count has increased. So you saw that as I am moving my pointer, and you will see that it will actually go and finding all the possible INJ pointers, which is finding all the possible sub-arrays. With this building of sub-array itself, I am finding the count of consonant and vowels. And with this count of consonant and vowels, I'll just meanwhile go and parallel check these two conditions and simply keep on updating my answer. If the conditions satisfy, increment the answer by 1. And that with this, I can simply get this solved. Let's quickly code this up. It is a pretty easy one, so that's the reason we are not going much into deep one. In question 4, we'll actually go on to very deep. So let's quickly code this up. Now in this, you will see that what we are doing. So as you saw that initially I want to have an answer. Now as you saw that I will go on to every of my substrings. So I'll go on and I'll say, firstly, let's have a n variable as length. So I'll just say it is s dot length, right? It is s dot length. Now I'll just go on to my entire length, and then, but as you saw that I want all the substrings, so I'll just go on to my entire substrings also, less than n and j plus plus. It should be more than equal to I, right? I want all the substrings itself. Now when this is the case, from I to j I have a substring, but as in like I'm just counting off my vowels and consonants incrementally. So have a count of vowel as 0 and count of consonants consonants as 0. Consonants as 0. Now I'll just have a quick check if this is a vowel. For that you will see that how we can check it. If this is a vowel, now vowel is for this current character, which is actually our S of what should we say? It is S of J. If that is a vowel, our current character is a vowel, then what should we do? We should simply increase the count of vowel. As simple as that. Count of vowel will actually be increased. Count of vowel is actually increased, and do plus plus else, which means it's a consonant. So count of consonant will actually increase. Now, again, we have not formed what's a vowel, what's a consonant, but yeah. Now, we can quickly have a check that the condition which we have. If the count of vowel is equals to count of consonants, and also there was one more thing, that the count of the multiplication mod k is actually 0, which means count of vowel into count of consonants mod k, because that I need to mod with, if that is actually equal to 0, which means I can increment my answer, and ultimately I can just simply return the answer. That is how you can simply solve it. Now again, this is vowel was still remaining, so let's have a quick check that bool. Now have a quick check. Bool is vowel with this particular character C. Just check. Now one thing which I think of is that we can have a string S, let's say A, E, I, O, U. If this character C is inside the string, so I can just say that if S, this is last chat someone told that we can use this particular STL. So S dot find C, if it is not equals to it was, I guess, NPOS, right? S like string NPOS, I forgot, but yeah, I guess it was this. If S dot find C is not equal to string dot NPOS, which means it is inside, so simply return true, else return false. I hope the syntax is correct. I forgot the syntax though, but we can simply have Google check if we have forgotten the syntax. Let's quickly have a check if the syntax is correct. It seems like the syntax was correct. So yeah, that the syntax was correct. So it is just that we just made a string of the AIOU and then just checked if the character was inside my string. And that is much more beneficial than rather than writing all the conditions if the character C is A or this or this or this and so on and so forth. Cool. Now let's quickly have a chat read and then we'll quickly go on to question number 3. But before that, can we please smash that like baby to 30 likes? That would be super great. But yeah, we'll go on to question number 3. A quick chat read. 29 plus contest, no worries. Adisha, see, like that is what we need to practice for. Still, for question 3, it's just that just let me know that what intuition at least you thought of that might work or that might not work. But yeah, I have seen, I have also done many contests, and still there can be a chance that you don't, it doesn't click to you at point of time. It is very highly possible, but that is what now. If you will not fall, you will not get up. It's a one kind of question which you remembered. Do you think Q1 was harder this time? Yeah, I for sure think. I think that question 2 was easier than question 1. Considering, yeah, I'll think that part also. Yeah. Akshansh. Yeah, great. 8 minutes for the first question, 20 for second question. Okay. Sure. Sordhya. For question number 2, it was a bit long time considering it's a very standard sub-array question. So yeah, we can actually get this timing of the question number 2 to for sure under 5 to 6 minutes. Because it's possible. Question 1, I can still think of it. It can still take 8 minutes or might be more because it was a bit different and not that easy. But for question 1, it can for sure be decreased time. Can you provide another sheet for all concepts? Sure. Like, yeah, that's the reason. Like, whenever I find any good question, if you have not known, so what I do is, if you just go and search Aryan Mittal, so that's the reason. Like, what I do is, I have this playlist in which I have this top 150 questions. Where is that gone? Let's find 150. So yeah, top 150 interview questions. So whatsoever question I find of is of different variety and doesn't fit, I keep on adding in this top 150 questions playlist. So that is, now you know that if you do any of the sheets, like you see question keeps on coming regularly, and it's just a type which is something different, which blows my mind, I will add in this particular sheet itself. But yeah, it's a weekly contest, so I just add a daily questions in that sheet. So whenever this question comes in daily contest, daily problems, I will add this in the sheet also. Cool. We'll quickly go on to question number 3, then we'll go on to other chats. S.end bhi kar sakte hain na? Let's try. S.end kar sakte hain ya nahi? I don't think S.end works for strings, because I've never seen this fact. Yeah, S.end doesn't work. It's just string and NPOS, which works for strings. Cool. We cannot do S.end because it's not a set, or it's not a map, or it's not a the set of data structure. Can we go to first extension for second one? TGOT, we always go in the regular fashion, no matter how the questions are hard or easy. But yeah, we'll quickly go on to question number 3. Make lexicographically smallest array by swapping elements. Now, again, if the folks have not smashed that baby, like you like smashing the baby, smash that like baby. Cool. Make the lexicographically smallest array by swapping elements. Now, you are having a 0 indexed array of positive integer nums and a positive integer limit. Okay, great. In one operation, you can choose any 2 indexes I and j and swap those, provided their difference is less than equal to limit. Their absolute difference is less than equal to limit. That is the only and the main condition for us. That's it. Now we have to return the lexicographically smallest array. As you can see that if I can choose the 2 indexes, I can just swap those if they are within the limit. So I'll always try to swap them. And when I will try to swap them, I'll just try to have the lexicographically smallest array, which means in the best lexicographically smallest array. And it just says how we can have a lexicographically smallest array. Now we will just see this particular example itself. Now it just says we have nums is actually 1, 5, 3, 9 and 8. Now my limit is actually a 2. Now just imagine one fact. Here I asked you that you can swap 2 elements. Okay, so firstly, forget that your limit is 2. Imagine your limit is infinity. You can swap any elements whatsoever you can. Or I'm just saying there's no limit at all. You can swap every element you can. So which means you can swap this with this, 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 and so on and so forth. So ultimately, what you will get finally will be a sorted array, which will be the lexicographically best array. So you will get the answer as 1, 3, 5, 8 and 9. Right? Now, one thing will come. Aryan, okay, what if the limit would have been very large, which means you will see the limit is the element's difference. I'll say the limit is very large, which means limit is 9 minus 1, which is 8. It's the maximum limit, which is equal to infinity. This is for this array, this 8 is equal to infinity itself. So one thing, you can do a swap. What you think of this as a swap? Do you think that I am just plotting one part? I am just saying that I can swap 1 and 5. Then I am also saying, again, let's leave this, and I say I can swap 1 and 5. Here I am saying I can swap 3 and 5. Here I am saying I can swap 3 and 9. Here I am saying I can swap 8 and 9. I just took one of the random elements for swaps. Now, if you look at this, and if you look at the final answer, see, why I only plotted just 1 swaps? Because no matter what, if the limit is there, you won't be able to plot all the n square swap lines, because you know that the n is pretty large. So for sure you cannot plot all the n square lines or n square swap lines. So here I just plotted some of the few lines. Maybe like it is not required, maybe required, but I just still plotted some of the few lines. Now this says that I can swap 1 and 5. So 5 can come here. Now I can also say the same thing, that 3 can come here, 5 can come here. Now again I can swap these two locations, right? I can swap these two also, which means I can swap 5 and 3. I can also swap 3 and 9. So ultimately I can say I can also swap 3 and 9. Why? See why? I can swap 3 and 5. So 3 can come here, 5 can come here, right? Now I am saying that I can always swap 3 and 9. So for sure 9 can come here and 3 can come here, right? Now I am saying I can swap 5 and 3. So 3 can come here, 5 can come here. So you saw that the 5, it can come here. It also came in middle. It also came in this location. So for sure, when I can swap these elements, let's say this is not there, I can swap these elements. So I can just order them in the ascending order itself. I can just group them and I can say, okay, I can make them as 3, 5, 9 because it is the best lexicographically possible way for me. Agree on that part? So right now we have just known that, okay, I can just plot some of the swap lines. Now with those swap lines, I can know one thing, that I can group those up. And for sure, when I group those up, now when you just hear of this word swap lines, you might think of a graph. Then you might think, okay, I'll group that up, which means you might think of components. Now grouping that up, components, okay, it's a graph. So maybe you might think of it as, okay, I see this as a bit side. Cool. Yeah, it's okay. So with this, you might see that I'm just kind of making lines, which means edges, and I'm kind of making a graph out of it to make the components. So that is kind of, again, I'm not saying it's a graph problem. We will not solve it via graph. It's just that we are thinking of it. We are making groups. See, thinking comes parallelly. Again, I'm saying, I told you, but we are not gonna solve this with graph. But still, it's a thinking which is going on in our mind right now. So what we realized, one fact is that if I have some edges connected, I can just make a group and I will for sure try to sort them up in the ascending order so that I can get a 3, 5, 9, something like that. Why simply sorted? Because I want the lexicographically smallest array. So simply group. If I have a group, it is always good to actually sort it so that it is lexicographically smallest and then place it up. Now coming back to the actual question. What was the actual limit? Actual limit was a 2, which indicates how should I actually make my edges. With this one, with whom I can place the edges. I can place the edge with a 3. And again, shall I look for something else also? But again, if I will go on and look for all these other stuff, you will see that as if it would have been an 8, then you would have been and build a O of n square edges, which is not required. So what we will do is, we know that the limit is actually 2, right? Or whatever the limit is. I am just kind of checking the difference, right? And this difference, if this difference is less than equal to my limit, then I will just plot an edge between them. Again, I'm saying a word edge as in I mean the swap line. I'll plot an edge between them. So you want this part to be as low as possible, as low as possible. You want this left part to be as low as possible so that it comes in under my limit and then I can plot a line between them. That is one thing. So what I can do is, I want this difference to be as low as possible. When you want the difference of two elements as low as possible, you just try to sort them up. So what I will do is, I'll just simply try to sort them up. I'll make a 1, 3, 5, 8 and 9. But you forgot one thing. You actually have to find the lexicographically smallest array. So if you just simply sort this up, so you might forget its actual indexes. So please also parallelly keep track of the indexes. Indexes 0, 1, 2, 3, 4. So its indexes 0, its indexes 2, its indexes 1, its indexes 4, its indexes 3. Now these elements which are in orange color are as close to each other as possible, which will make sure that I can just try to plot an edge between them and make a group of them. I'll just check, okay, if these two have an edge between them or not. How to check? If their difference, which is 3 minus 1, if this is within the limit, so they have an edge. So okay, these two have an edge. Great. I'll just mark them with an edge. Or what I can do is I can just say, okay, I will just marking them an edge, which means clubbing them in one group. So I can simply say I'll just club them in one group. I'll just show how to write that in the code, but yeah, it's just giving a feeling of clubbing them in one group. Then I'll just go and check this 3 and 5. Oh yeah, again it is actually having this value. Oh great, if it is having this value, simply club them into this same group. Again I'll go and check this. Bro, 8 minus 3 is more than the limit, bro. So a new group will start from here itself. It is in a new group. Okay, 9 minus 8, it's actually 1, which is less than or equal to 2. So it is again in the same group as that of 2. So now you will see that my elements 1, 3 and 5 are in one group, 8 and 9 are in one group. And as I told earlier, if something is in one group, I can just simply sort them up, right? Aryan, it is already sorted. No. Sorted it is already, but I want to place them at these indexes, right? So now let's imagine these are the empty places which I have to fill, right? These are the empty places which I have to fill. These places which I have to fill, right? I have simply sorted this up. So now I will know, okay, the elements I need to place are actually 1, 3 and 5. The indexes on which these can be placed are actually 0, 0, 2 and 1. Simply 0, 2 and 1. Yeah, right. Simply sort these indexes also. So I'll just sort these indexes. I'll get a 0 or I'll write here itself 0, 2, 1, but simply sort them up. So you will get the values as 0, 1 and 2. It will just say me that this element will come at location 0, this will come at location 1, this will come at location 2. Because internally in this group, I can sort them up and will try to place them as lexicographically order as possible. And now for this also, it is one group. Simply it is already sorted. So you know the elements are 8 and 9. You know the indexes are actually 4 and 3. You will simply sort these indexes. You will get indexes. You will sort these indexes. You will get a 3 and 4. Simply place these indexes. Place these values 8 at index 3 and 9 at index 4. And with this, you will get 8 and 9. You saw, and here you will place 1, 3 and 5. So with this grouping part, you got the smallest possible lexicographically array, and that is this. Again, just for a bit simplicity, we will actually, just for a quick check, we actually solve and try on this also. How? Let's see. We have our nums. Let's have our nums. We have our nums. What is our nums? It is 1, 7, 6, 18, 2 and 1. I have my limit as actually 3. Now again, as I showed you, that what primarily we want is elements to be as close as possible, so that I only should be placing maximum one edge between them. So I know the indexes are 0, 1, 2, 3, 4 and 5. I'll just simply sort them up. I'll have a 1. I'll have a 1 value. I will have a 1 value. I will have a 2 value. I will have a 6 value. I will have a 7. I will have a 18. So these are the values, but also make sure that you should not get lost with indexes. So get the indexes also. 0 is the index, 5 is the index, 4 is the index, 2 is the index, 1 is the index, and then 3 is the index. Okay, we have got the indexes. Now simply just try to see that who all are in the same group. Is this in the same group? Yeah, bro, the difference is 1. Same group. The difference is 1. Sorry, the difference is 0. Same group. Next, the difference is 1. Same group. Now the difference is 4. It is in a new group. Okay, difference 1. Same group. The difference here 18, no group, different group. Okay, it's in a different group. So now you saw that we have formed 3 groups. One group is this, one group is this, one group is this. We have formed 3 groups. Now Aryan, how to form groups? Shall we use a graph? Shall we use something else? I'll say simple. Wait, you just want a group. right? So you can just say that I can have a one group. Now in my one group, let's say I name the group as group 0. Now this group 0 will have these pairs. So I will have a vector of pair. I will have an unordered map, again to unordered map from a key which is int to a vector of pairs. See, again, this can be optimized, because if you just think of if you have an index, you would not need a value. So you can just use only vector itself, but still for simplicity, I'm just keeping the vector of pairs itself. Now, and when I say optimized, I don't mean the actual optimization in the space or time complexity. It's just a bit optimization, a bit. Now, this is one group. So again, I know that for this particular, when the elements are in this order, and let's say if another group comes in, so I'll just push in some other key, which is a new key, and I'll just start off with this other group, right? And then let's say some other groups comes in, I'll just push in some new key and start off with this other group. So these are three groups which I can make. So I would not need to make a graph structure. I can just simply use this particular unordered map to a vector, just saying key is a new group which I have formed, and in that corresponding key will give me all the corresponding values. Okay, now when, as you saw earlier also, when we have formed the group, our main task is to simply sort the elements in that group itself and assign the indexes. So I know the elements are just in the order itself, 1, 1, 2, but the indexes may or may not be ordered, which are actually 0, 5 and 4. So simply sort this up, you will get a 0, 4 and 5. So simply you know the final answer, that the final answer, which is nums 0, 1, 2, 3, 4 and 5, you know that at index 0 you will place the element 1, at index 4 you will place the element 1, at index 5 you will place the element 2. Right, now you have placed these elements right here. Now, okay, when this is done, go on to the next group. You will know the elements are actually 6 and 7. The indexes are actually 2 and 1. Simply sort them up, indexes, so that you place the minimum. Why are you sorting it? So that you place the minimum element at the lowest possible index. Okay, I'll just place 6 here and 7 here. Last is this group, element is 18, ID is just 3, sorting it up is still 3. I'll simply place the 18 here. That is the final answer. You will see that is our final answer, 1, 6, 7, 18, 1 and 2. And with this, you would not, although the logic internally is a graph logic, that you are using the entire thing, you are using a structure and all that stuff, which means like you are making a group club. So you will see that people can solve this with DSU also, people can solve this with DFS plus components also, which means doing a component on DFS. People can solve this as we can solve with simple arrays and unordered maps, arrays and maps also. So that is how anyone can solve these questions. Cool. Let's quickly see that how we should code this up. Again, there can be multiple ways to keep track of this. We will find our way how we can keep track. We can just, again, that is the most interesting part. See, the only interesting part of this problem is how will you maintain the groups? How will you maintain the groups? And it is the only part where you will actually see that we might struggle. Cool. Let's quickly go on to the next question. Let's reset this bad boy up and let's simply code this up. So you saw that ultimately I want the answer. Now the answer will be of the same length. So it's good that firstly let's get the nums.size. Now I have my answer of size. By default, let's say a value 0, although like I'll just modify the value itself, but yeah, by default let's take the values like this. First and foremost thing, make a pair, vector of pair, because you saw, right, I need to sort my elements itself so as to find, okay, what two elements to make a group of. So I'll just make the element and the index pair. So I'll just say a pair kind of thing, right, or basically vector pair. So I'll just iterate on my entire array, I equal to 0, I is less than n, I plus plus. Let's remove this. So with this, I have got the index. So I'll just simply push this in my push back in my pair itself. So firstly, the first more thing is the index. So sorry, the element nums of I, and rest next is the index. Okay, now simply sort this up. Sort this vector pair dot begin and then vector pair dot end. Now when this entire stuff is sorted, now the actual fun part begins. How? As I showed you, I can go and track my actual groups. So for that, I'll take a key and I'll take a vector of pair to keep track of what is the actual elements and the indexes. So it's a map for me. Now I'll go on to all of my elements in this array itself, which is the v pair array, which is of the same size of n. So I'll just go on in this v pair array entirely. Now I also wanted to maintain a group ID, right? So let's say and check, okay, my GID, group ID is initially a 0. Now, what will happen in the beginning is, I'll just have a quick check. Firstly, what if it's a starting element, so I cannot check previously, right? If it's a starting element, I cannot have a check previously. So if I is 0, if the I is 0, then simply just push back that element. Or, okay, if the I is 0, then and just simply push back this element in this existing group ID, which is 0. So what I will do is, I'll do a map of this particular group ID. I'll just push back my this particular pair, which is the current pair which I am getting, which is v pair. Okay, which is v pair of I. I just push back in my grid. Oh, this map, right? I just push back a pair. Now, it's good that you push back it, but what about the next element? For the next element, you might go and compare the values. If this value is more, which means if the value is more, then you might increase the group ID, right? If the value is more, you might increase the group ID itself. So, what shall I do? You might think, see, what will happen in this? You are just pushing that element right here, right? Now, I am saying if the value would have been more, you might have increased the group ID, right? That is true for sure. So what I can do is I can just initially have a -1 as group ID, and I can just say this thing as outside, so that initially my group ID will actually increase. My group ID will increase, and then it will actually push back in my element. And then how it can handle the other cases, what if the difference between the elements is actually more? So I just have a check that the current element, or let's have this condition, the difference. You saw that this is the difference I'm talking about. This is the difference I'm talking about. Nums of I minus nums of j. The two consecutive element difference. So I'll just have a check that v pair of this particular I dot first, right, minus, because first contains the actual value. Second is the index, not the value. V pair of I dot second. Sorry, dot first. But it is I minus 1. But now, Aryan, what about the condition of 0? Oh yeah, that's true. So we can actually put this entire stuff into our loop, into our condition after I. Now, okay. Now if this difference is more than, because you know less than equal to is correct. If it is more than my limit, then bro, please increase the group ID and then try and do something else, whatsoever you want. So with this fact, my group ID will increase. I'll just have a new group ID and then I will be pushing that in my element. Else, if the limit is still there, then in the existing group ID, that will be being pushed. Okay, now with this fact, my group IDs have been formed and I have all the groups being formed. Now comes the interesting part. You have to actually go on all the groups. So I will have the pair. I'll go on to all of my groups. So I'll know that group ID is actually p dot first, but I don't need a group ID itself, right? No worries. Yeah, I don't need a group ID. I just need the elements in those groups. I just need the elements, or basically the pairs in those groups. right? So I say, okay, it's a V pair. It's the same, so I just say a VP. VP is nothing but the pair. It's a vector of pairs for that group itself. For that group itself, right? So I just say P dot second. Now for that group, as you remember, for that group, I'll just show you. For that group, now you have got this group. Elements will remain as it is. Indexes I will get. So what I will do is, I will know one thing, that my elements are in the VP order itself. Although you can just go and have another array of, let's say, elements and also the indexes. So what you can do is, you can just go on to all of the values in your this particular VP. It is nothing but a pair. So okay, it's a pair, another pair, so let's name it as value pair. Now you will just go on to the value pair. This will actually store two things, which is, one is your ID itself, one is your element, and other is your ID. So I have just used the variable, so let's name it as V pair VP. What should I name it as? Let's name it as P2. It's a P2, a pair 2. So just will happen that I'll just push back my P2 dot first as the elements, and ID will be nothing but these indexes. Push back P2 dot second. Again, you would not need to monitor this elements because the elements are already in the sorted order. You don't need to monitor that. But still, for simplicity, we actually grabbed elements and indexes all together out. Now I will just sort the indexes as I showed you. So I'll just say id dot begin, and I'll do a id dot end. Now I have sorted my indexes out. Indexes are sorted for sure. I will now go on to all of my indexes, right? All of my I's in your indexes, IDs. I'll go to all of my indexes, and for this corresponding index, I need to place in the corresponding value of element. So let's have it in the index based. So I'll just say I equals to 0, I is less than id dot size, and I plus plus. For this corresponding answer, which is answer of that specific index I, my answer will be element of I itself, right? And then with this I will be doing for all the groups and ultimately returning the answer. Cool. Let's quickly see that if this runs, or if you have not done any mistakes. V pair, did you mean V pair? Where is this? Line 8, V pair. It's same, right? What it is asking, V pair or pushback of this pair. V pair. What's trying to say? Use of undeclared variable. V pair. So V pair I have used, right? V pair. Okay. Error. Use of undeclared variable. V pair. Oh, this is vector. Okay. This is the thing which it is still showing same error. Line 27. Why my vector spellings are always incorrect, right? Cool. 1 3 5. Okay, the other groups did not come in. Okay, the other groups did not come in. You will see only the first group is coming in, the other groups are not coming in. And this also is kind of an issue which we have done a blunder greatly. Let's see what blunder we have done. We have portioned the indexes. We have also sorted the indexes. When we sorted the indexes, we went on to all of our pairs, V pairs. Now in this V pair, answer of ID of I. Yep, that's correct. Answer of ID of I. Answer of ID of I should be equal to element of I. Now 13589, 1678112, and 172819 and 10. That's, thank you so much, Eklavya. And that's how, because of Eklavya, that question got solved. So you saw that, and again, this element maintaining is not required because you can actually use this VP itself. And again, this unordered map of int of vector of pair is also not required. You can easily use an unordered map of int of vectors itself. That also is more than sufficient. But still, for simplicity and for easy visualization, we use these variables. Cool. We will go on to comments and then we will quickly go on to question number 4. Again, for question number 4, you will see many easy solutions on Leetcode, but later on with time, these solutions will not work and they will start giving DLE because they are O of n into roughly average of n solutions, which will not work later on. Right now, the test cases were not that strong, so many people got it correct, which is around 400. If you just go and see, 400 people got it correct, which is not a good number for this problem considering it's a hard question. So I guess around 100 people would have solved it max to max, but still, we'll go on to it. Let's quickly have a chat read, but before that, can we please smash that like baby to 45 likes, to just 2 more? That would be super great. Thank you so much, the Chitri Eklavya. I'll say Eklavya. Vector spell check. Thank you so much, Code and Code. Sonal, hey. Pratyush, hello bhai, profile karoge aaj review, it will be helpful for me. Yeah, sure Pratyush, just mention your Leetcode profile, your username. We'll for sure review it, or better, just give the link of your username itself. Now I get where I made a mistake in question 2. It is such a silly mistake. Akshansh. Yeah, definitely. Question 2 was easier than question 1. Yeah, true. That's Kunal. Akshansh. Ritik, bro, I was watching Deep Intuition building playlist, still struggling with developing recursion relationships. Recursion relationships. See, I'll say 60% of problems are just take and not take, use not use, throw not throw, like this, which will solve the 60% of the problems. Firstly, make sure that you are comfortable with that, and then we can actually go on to much more problems. Again, when you solve or watch any playlist of mine, just make sure you watch the intuition playlist, like intuition part, then stop, pause the video, go back to question, solve it. Watch progressively. Always watch my videos progressively. Pause it, go back to question, solve it, come back, watch it again. Still, even if you get this solved, still it's it's good to actually watch the entire video completely, because who knows, I might have told you something good in code or maybe something better in the logic itself. But yeah, your practice plus watching the intuition building playlist is actually what's gonna help you. Again, that's a progressive and that takes time. Like I know for sure, I have been in that stage also. It takes a lot of time, but still it takes the consistency, which is the prime part. Cool. Yeah, I'll try my best next time. Great. Sorry, Sohardya. Start traversing from left to right and only check for elements to the right, as the elements on the left have already been checked previously. That's true. Hey, let us spell check. Okay. Hi Klavya, hi, I am from MNIT, bro. I am from mechanical and trying software. Due to less hiring, I am not even getting interview chances. Can you suggest me any idea to do internships at least? So like there are Naukri.com. There's like LinkedIn. I'll not recommend LinkedIn as a very good platform for Naukris, but yeah, it will still get you show the available posts or openings. But again, I for sure know that I have talked to many students offline also, and it's an issue that they're not getting offers or vacancies. Try off campus. Eklavya, your coding is great. So that is one fact that we can actually utilize that fact and try off campus a lot. When I say a lot, try for every, just post and just apply in every day, apply in 10 companies for internships. One or the other, even startups will actually call you. So, and again, for startups, you might actually be needing some dev knowledge also. So parallelly, maybe, if not entirely this, parallel start watching that dev part also. Again, there are some channels, Code with Harry and all that stuff. They can actually teach you dev part also very well. So maybe if you think that if you think that you are like, you tried very hard but still you are stuck, let's say if you are trying very hard but still you are stuck for the entire 1 year on, let's say, just solving 1 and 2 problems only, and when I say stuck, I actually mean no progressive improvement. And what you mean by progressive improvement, I have already told. There are 5 steps of improvement: question understanding, question intuition building playlist, question understanding, question intuition building, question solving, question like actual problem solving, problem code logic, and problem code implementation. So if you are progressing in any of these 5 steps, then it's a progress. If you are stuck at any step for very long, then I'll recommend that parallelly start switching to something else also. When I say parallelly, please make sure that you continue with this, because this will give you a wide variety of opportunities with just minimal effort. When I say minimal, it is just that you only have to study DSA, and that will be more than sufficient for you to grab many offers. It will open a whole lot of portal, and that is not for now. Okay, like my college is finished. That is not for now, just now. It will for your entire career. No matter for 5 years down the line, if still I want to switch, I will have to do DSA and DSA. That's most important. Cool. And my projects which I did in college would not be mattering, because the companies, they will ask me the projects which I did in my company and not of what I did in college. So that's the reason. Your projects which you do or the dev which you do in college are only significant unless you get to a job. As you get to a job, as soon as you will make a switch, they will ask you something which is from your previous company and not from your projects of college. Cool. Let's quickly go on to question number 4. Before that, can we please smash that like baby to 50 likes? Just 5 more, that would be super great. Yeah. I know that we got a bit late because of all this stuff, my issues of OBS, but that's a Mac issue. Like, even after having 16 GB of RAM and MacBook Pro, still it lags a lot. Like, I don't know if it is me or like what I'm doing wrong in this, but my MacBook lags a lot. It just hangs. I'll show you. See, what will happen. So if I just open my Telegram, so like you saw that this was thing which was happening in this, and then previously also like it was just showing this part. So I don't know what the happens with my Mac, but yeah, cool. You are given a string S and a positive integer K. It's the same question as out of question number 2. We have vowels and consonants. Maybe the number of vowels and consonants in a string. Now, again, it's the same question exactly as what we saw. Vowels count should be equal to consonants, and vowels into consonants mod K, which means the length of vowels and the length of consonants mod K should actually be equal to 0. In other terms, multiplication of their count of vowels and consonants should be actually divisible by K. Now we have written the number of non-empty substrings, same as that. A substring is a continuous subsequence of characters, and like this. Now, if I go and ask you one thing, let's imagine one thing. If I go and ask you, bro, if you had an array, again, I am just breaking down the problem for you to build the intuition. If I would have asked you if you have an array, and if I would have asked you, bro, give me all such count of sub arrays, because that is what you wanted. It's a substring or sub array, both are same. I'm asking you, give me the count of all these sub arrays, where two things have same frequency. Now, bro, I am just saying you, just imagine that in your entire array ARR you have only 2 values, X and Y, or let's, for simplicity, you can have a 0 or a 1. So now I am saying you, bro, just do one thing. If you know that the elements are only 0 or a 1, just give me the sub array count. Just give me the sub array count which will have 0 and a 1. Only 0 and a 1. Bro, the entire array has 0 and a 1. No. 0 and a 1 with equal count. Okay, bro, equal count you want. That is true. So shall I keep track of the count of 0 and 1 in this entire array? Which means if I want specifically for this sub array, so you know that whenever you want some information for a sub array, you might choose to say, okay, I can maintain some prefix and I can subtract the prefix of some part. Let's say if it is I, it is j, I can just have a prefix of j, I can have a prefix of I minus 1, and I can just get the answer for this. But bro, here you wanted that the count should have been same. Bro, to maintain the count for any sub array, I just know one concept to find easily is just using a prefix. So bro, what prefix should I maintain? Bro, do one thing. You know that you have a vowel, which means you have a vowel and you have a consonant, right? So let's say for vowel, you can have a 1, and for consonant, you can have a minus 1. Now with this fact, what will happen is that if I say that, okay, the array looks something like let's say E, C, A, B, here if it is F, it is G, it is I. It is my string. It is my string. Now when I am trying to build this prefix array, before building that prefix array, just see that corresponding to every string character, what value would I have? I will have a value. It's a consonant, do a minus 1. Okay, it's a consonant, do a minus 1. It's a vowel, do a plus 1. It's a consonant, do a minus 1. It's a vowel, do a plus 1. It's a consonant, do a minus 1. It's a consonant, do a minus 1. It's a vowel, plus do a plus 1. Now I can keep track using a prefix. So I'll do a 0 minus 1. It will become a 0. It will become a minus 1. Okay, it will become a 0, it will become a minus 1. Now it will become a minus 2, it will become a 0. So whenever you want to find some prefix, what you go? You just go and say, okay, bro, it is a minus 1, right? I'll just go and check whosoever is a minus 1 for me, whosoever is a minus 1 for me, whosoever is a minus 1 for me, just will say me that if I just subtract this value from this, I'll get a 0, right? Ultimately just saying that I want the same value. Again, you can also have it as a 0, 1, any values you can have any values corresponding to it. It's just that you will just maintain it as a prefix sum, and this prefix sum will tell you one thing, that bro, from here to here, if the element are same, which means if this is same, 1 minus 1 minus 1, if this is same, for sure I can just subtract it, and this will see me the entire sum of this entire part is actually a 0. You will see that, or you can just easily go and maintain that fact that this, you will see E, C, A and B. Okay, so what I did here, I just kept a track of my elements. Now what if bro, you are having a 0 here, I'll find another 0 here. Yeah, that's a A and a C, vowel and a consonant. Bro, no worries. What if I have a minus 1 here, I go minus 1 here? Yeah bro, that's same. Again, you have a E and a C. So you saw one thing, when you are finding this count as same, something as same, so this will make sure one thing. If you have your 0 here, you go and find another 0, bro. So for here to here, are you saying the count is same? B and G, the count is not same. It doesn't feel good to have something like this. We did something wrong. Let's see. For sure, it doesn't feel good for us. So we might use something else instead. Now, okay, earlier we were taking the vowel and count. But we want something that we can just keep on maintaining. That okay, if I am at this value right here, so I can just tell at any point, okay, I am at this value. So whatsoever value I have here, I should be saying that this point is actually a good point for me. This from I, J, J, A, this is a good point for me. I should be telling this point. This is a good point for me. Now, how to tell this fact to the problem statement itself, that this is a good point for me, that this is a good point for me. For that, you will say that, bro, what I need exactly is that my sum of this entire thing is actually 0. So you will see that the sum of this part is actually a 0. So sum of this part is actually a 0. Sum of this part is actually a 0. So for sure the sum of this part is a 0. Again, the same way. So when I'm placing a plus minus 1, so it just says the sum of that portion is actually a 0. Now, how you find the range sum? How you find the range sum? You find the range sum by just simply saying, okay, prefix of this value minus prefix of this value will give me the range sum. Will give me the range sum. And I want the range sum to be 0. I want the range sum to be, I want range sum to be 0. And I was finding the range sum also previously. So again, I can just write the same stuff because we are doing correct. We are finding the range sum, and that was what we wanted. We do have a 0, minus 1, 0, minus 1. It's a minus 2. It's a minus 1. So I know that if I have this as a prefix value, prefix of let's say I, and I will go and find the same value. Why I want the same value? Because if I subtract the same value from me, I'll get the 0. If I get the 0 as a, because prefix of I minus prefix of j, if this is a 0, which means I have got that specific sub array which have equal number of consonants and vowels, because I have marked one as positive, one as negative. So the range sum is actually 0. So the range sum is 0 indicates that I have equal number of consonants and vowels in that particular range. Okay, that is great. That is done for me. That is, I just simply mark it up. The same I can do, minus 1. I just go and find another minus 1. So this will indicate, okay, if I have a minus 1 here, this is one range. You will see G and I. That is a good range. Again, minus 1. This is one range, which is again A, B, G and I. That's again. So this is simply one thing we have got so far is how we can actually get to the point that we are actually having a count of consonants and vowels as equal. With this fact, I can maintain and keep track. Okay, my vowels will have a plus 1, my consonants I'll do a minus 1. I'll maintain a prefix sum array. With that prefix sum array, if I am at the index I, I'll just go and find, sorry, if I'm at the value I, value as in minus 1, I'll go and find for other values I, which means this and this. This will make sure that I have equal number of consonants and vowels. So first condition has been satisfied. First condition I can solve by simply using a prefix, and I can just simply move on, simply keep on moving in the prefix. Now, is it sufficient? No, it is not, because consider that, okay, you have an I, you have a J here, right? So you want other condition also, which is vowels into that consonants mod k should actually be equal to 0. So that is the other condition which you wanted. Now, how will you solve it? One thing we got to know so far is that this length is L. Now, if this, again, this condition shows that the length was L, if the entire length was L, from J to I, right? From J to I, the length was L. You wanted one thing, that the length was L, which means vowels plus consonant length was L. I know that vowels and consonants are equal. So vowels length equal to consonant length equal to L by 2, right? So I know the length is L because I have found, I am at the index I have found other index, previous index J. I have found these two indexes. For sure, with that, I would know what should be the length of this, but I want other condition to be satisfied. So I just using my current length, because of my current observation, I have my I and J. I will know the length for sure. It will be nothing but I minus J. Length will be nothing but I minus J, right? That will be my length. And also I know one thing, that my vowels and count will actually be nothing but L by 2. I'll just substitute that to my second condition. So I will get L by 2 into L by 2 mod k should actually be equal to 0. That is my second condition, what will say me. With this, what I can say? I can say that L by 2 whole square mod k should actually be equal to a 0. Now, now comes the part that I have my L because I will be iterating on my prefix sum. So I will have my I. Because of my I will know the length which is there, because if you're maintaining the prefix sums, you would know the current value is this -1. So you can just maintain the current I itself. So you know this particular length kind of. Okay, the length I would know. The K is given to me. But I want to know if this length is actually satisfying the condition or not, because I cannot just go and try for all the previous J's. I just want that specific J which satisfies this condition. Again, for this corresponding I can go and find the length, but for finding the length I should be knowing what is the value. Again, that is not an easy question, but yeah, still we go on to it. For this corresponding I should know a J because of which I can find an L, but I cannot go in this direction. I cannot go for this I cannot go and find a J, because J can be multiple J's previously. So for every J I cannot go and find a L. What I'll do instead is I'll reverse engineer this. I know I am at I will find what could be the possible L, so that what could be the possible L, so that I would know that my this L square mod K condition satisfied. Now Aryan, here it is L square. So now Aryan, with this, let's say if you just imagined, if you have your L as I minus J, so your J will actually become a I minus L, right? Or you can say the J mod K will actually become a I minus L mod K, which is same as I mod K minus L mod K. So you wanted a kind of L mod K, but you have a condition like this. That's again an issue for you. So from this part, L square L by 2 mod K, can you figure out something that what should be your possible value? What should be a possible value? So that I can just simply say, rather than this, I can just simply say, I can simply transform this to a L mod K kind of concept, because I have this, I don't have the this kind of concept for me. If I have this, I can just simply use this concept. So now I will try to modify this existing condition, because I wanted to find the specific L for it. Now if we go back and see and factorize this particular condition, so L would look like anything. So I have a P1 E1. I have the example specifically for you also. So where is that example gone? That's not here. Cool, no worries. Like I just have it, let's say your L, I just factorize that L and I'll just make it as P2 E2, P3 E3. Now for you to say that, bro, my K should be having all those values, right? Or at least some of them. So I'll say I should have a P1, right? It should be something, let's say K, what should I say? K1, okay, K1. I have P2, I should have a K2. That should be there for K. Now, can I find the condition for this E1 K1 relationship? Imagine a simple number. You have to find a relationship between this E1 and K1, because you want to know that if you have a K like this, which is given to you, you have the specific L, which you can just go and try for all possible L's, so that you can just get to know that which L might satisfy my condition. So I'm just trying to figure out the condition for what my corresponding prime factor should have, that L should satisfy the condition itself. Now for that, what we can do is we have this E1, this as a K1. We know one thing, that if L is there, so it will be L square. So if I have L square, so it will be P1 E1 into P1 E1, right? So P1 E1 into P1 E1, right? And for sure I will have upon 2 also. That just forget this upon 2. Aryan, why to forget this upon 2? Because this length will always be 2 into something. This length will always be 2 into something, which means this length will always be even. Aryan, how you can say so surely this length will always be even? Because you know that my count of consonants and vowels are always equal. So it is that if the count is equal, so you will know that okay, v length is actually 2 into v. So length is always even. This L is actually 2 into something. So 2L is equal to 2 into something. 2 into something. So for sure 2 into something upon 2 multiplied by 2 into something upon 2 whole square. So this 2 and 2 will cancel for sure. Remaining will be this prime factor. Aryan prime factor, or prime factor can be 2 also. Yeah, we'll go on to it. But yeah, this prime factor will actually be multiplied. Remaining this 2 you have forgotten. This prime factor will become p1 raised to power 2 into e1, right? So you will figure out that it will be 2 raised to power e1 as a p1, and in k you have a p1 of a k1, and you want that this part should be big and should be get modulus by this part which should be small. So you will know one thing for sure, 2 into e1 should be greater than equal to your k1, right? Which I will just say that my e1 should be greater than equal to k1 by 2. Now Aryan, shall I take a flow value or a seal value? That we will take a seal value. Why a seal value? Take a simple example when your e1 would have been a 3. So if it would have been a 3, which means my raised to power 2, let's say p1 is 3, e1 is also 3. Again, p1 is 3, e1 is also 3, right? Again, when I say p1, it's just a prime factor of that number. Now for sure, if you say that your k1 like your p1 is still 3, your k1 you are saying is something, let's say 3 itself. So by this fact, if I will say e1 is not yet decided, so I'll just say if the k1 would have been a 3, is it good to say that if I just say 3 by 2 flow value is 1, so with this condition e1 as a 1 would have been sufficient? Is it correct? No. 3 into 3 is actually 3 square, which is not greater than equal to 3 cube for sure, right? So you want flow seal value. So you want that 3 by 2, you will get a 2. So your e1 should be greater than equal to a seal value of k1 by 2. So your e1 should have been greater than equal to 2. So it should have been a 2 or a 2. Now you have got the condition that on the normal case, again, what I mean by a normal case, we'll go on to it. But yeah, your e1 should be greater than equal to seal value of k1 by 2. That is one thing. Okay, sure. But here we considered that your L is something as 2 into something. Now your prime factor can be a 2 also. It is the only prime factor which is even. So your prime factor can also be a 2 because your prime factor can be a 2 also. So it can be a 2 into something, which is let's say 5. So this is already counted for us as a 2 into something, because we were saying we will cut these 2's. We were saying, so it is ultimately saying that I will just bifurcate this one. So I will have a 2 into e1, but specifically when your p1, when your p of I is actually a 2, then you would be wanting that your e1 should be greater than equal to k1 by 2 for sure. But you would want an extra 2 also, because you want to cut that 2 from the bottom. So specifically only for 2, you would want this condition. Now, okay, we have got 2 conditions. Now what? Like, because of these 2 conditions, this is for your exponential values, which is these e's and these k's. Now, I have got these conditions with me, which is my e1 should look something like this, e1 should look something like this. What I can do is that we have now got our e1s. Now what? We have got the condition, but if we go back and look, we had something like this, but it is now something like this, e1 into something. So it just says that now I have modified and I have just spoken that if I make my L dash, if I make something as L dash, just saying, if I make something as L dash, saying that just plot your current element this was your L, this is my K, which is the input. Now I'm just simply saying this one thing here, that now I just need to relate and bring it in the L dash location, that I can just, because I cannot parse this up L by 2 square, so I want in this form L mod K. So I'm just trying to build something that I will have a new K instead. So what will our K be now? That's a question. So it should be so it ideally should have been this specific K, this K. You will see we are actually trying to build as P1 raised to the power E1, P2 raised to the power E2, and so on and so forth, right? And so on and so forth. So this E1 needs to be actually greater than or equal to K1 by 2. Now this should actually be greater than K1 by 2. Again, like if this P2 is a 2, K1 by 2. Okay, we should actually have a K with us. Yeah, that's a bit confusing here. How shall we proceed with this? We have got now we are actually trying to formulate our simple equation with these existing equations and this equation right here. So we have these three equations, this one right here, these two right here, and this, like ultimately we want something like this. So what can we do for this? Let's see if we can do something for this. If we try and go back and see, look at the question. We want to have, we can go on to all of our elements. Then we want to have the frequency of a prime factors of this element K. When this is done, and if this frequency I have, which is K1, so with this frequency as K1, we will have a seal value. Then with this seal value, I can go and generate my this number L. So I can go and say that my L is the number, expected number. It should have been a P1 raised to the power E1, P2 raised to the power E2, and so on and so forth. Right? Yes. So the current number which is right here K, it is, we are trying to build something of a sort which is a better K now. So we have to modify, so like this is a better number we want. Let me think, because we are missing something and we want that part too, right? Okay, what can we do for this? We have a P1 raised to the power K1, we have a E1 also. Now we want to build a new number, if that is a power which we wanted, which means for that value P, if for that corresponding prime factor P, if I have the count of its values as P, I would want this count, which is actually K, So this new k, let's name it as k new, right? K new. So this new k, or basically new e, you can also write this same thing as new, it's a e, that's a new e, so it's existing e, let's say. Let's not modify this. Yeah, so if you have a k new, if I have to make, so just to say is that to satisfy this condition of L, I would be wanting a new e. Okay, that's a bit confusing, but we'll still solve it. So we have gone on to this specific number, which is p. For that specific prime factor p, I will go on and check for that prime factor p if it can divide my k. I'll get the prime factor p, I'll get the count of that, which is actually k1. I'll get it that to satisfy my L, if I do a k1 by 2 seal value, so my k new should look something like this, which will make sure that my k new should look something like this. So I'll say, okay, my p1 of k new, let's say k1 new would look something like this, multiplied by p2 into k2 new, right? Now this ultimately, I was dividing my this equation, I was dividing my this equation with a k, right? Now I can divide my only L with this particular k dash of new. So earlier I was dividing my L by 2 whole square mod with k. Now I am saying I am dividing my L with this new k dash, because we tried to find from this k a condition to L. We tried and wanted this to give a 0. So we tried to find a condition from k to this L by 2 whole square and stuff. With that, we modified our k that it should directly divide our L. We modified our k to directly divide our L. So how we did was, we just directly have modified the k, and this k1 new, or you can just say as even also, even as a power. So with this, you have got this k1 new values as these, or k2 new values. Again, the k is k is this, so let's modify this and say as e1 or e2. But okay, let's leave it here. In the code we can actually modify that. But yeah, you saw that we have modified the condition from this to bring on to a simple modulo. Why we wanted a simple modulo? Because of the difference condition which we wanted. Now everything has gone very normal, that we have gotten a k new, right? We have got a k new. So earlier we had this normal k with us as the input, but because of this condition of I and j, I wanted something that I can just use this formula with me to get the previous location, right? So I wanted having some modulus operation directly being done on L. For that I need to find the operation on L, and I found the operation, but that can be done with the k dash. So I'll do it with a k dash, or basically k new. So now I have got the k new. I just simply now can apply my prefix sum, simply just saying that oh yeah, shit, again I did wrong. Cool. So as you saw that we had found this condition. Bro screen. Cool. No worries. We have found this condition of k dash new. How? Simple. Earlier it was just that our existing k was on top of the condition of L by 2 whole square, and then the modulus was being applied. But ultimately you saw that we wanted something as L mod k something we wanted. Why not use two loops? It will give a O of n square. No, that's the reason. Now, because you see that n is very big. 5 into 5 into 1e8 is actually not going to work. Now, it's might work in C++, but as soon as the test case increase, like get being comfortable, it will stop working. Now again, going back that we had a k on the condition of L by 2 whole square, but we saw that we wanted condition on L mod k. So what we did was, we simply went on and tried off to convert my k on this condition, simple L condition, and not a base 2 condition. For that, I modified the powers itself. So I just said, okay, if the existing L had a power of e, so for sure my e1 should be greater than equals to k1 by 2, and same goes for e1 when actually your p of I is actually 2. So you want a k1 by 2 plus 2, and it's a seal value. So with this, you got to know that your e1s would look something as this, but you know that you have your L and you wanted your k to be modified. So you know that your k, new k on top of this L, so that your new k can divide this L directly. Earlier it was dividing L square by 4. Earlier your k was dividing L square by 4, but you want to modify your k such that it divides L. So you modified your k that it divides L by saying that I'll modify my k1 by saying it will be k1 by 2 seal value, and for sure when the base is actually, the prime factor is actually even, it's 2, then it will be k1 by 2 plus 1. So now my k dash has become, which is the new k, it has become p1 raised to the power k1 by 2, when actually your p1 is even, multiplied by p2 raised to the power k1 new, depending upon what is the power they had, p3 raised to the power k2, k3 new, and so on and so forth, k2 new, and so on and so forth. It will simply keep on going. How? It's just that one thing, make sure if the p1, if the base is 2, make sure to do a k1 by 2 plus 1, because you want it, because 2 say 2, 1 will cut. With this, now you have got a k dash new, which will actually directly work on L. Now I can directly say that L mod k dash is actually a 0. If I am saying L by 2 whole square mod k is 0, I can say L mod k dash is actually a 0. Now this will actually make me help do one thing, that now if I am at any index I would know one thing for sure. If I'm at index I would know that I have to figure out some other position or some other values who have a same I mod, because see, this is actually a 0, L mod k dash is actually a 0. So you want some other index, and you are at index I, so you want some other j mod k dash also being 0, right? So you would know, you would just simply go in your entire array which you have built right now, this array itself of prefix, you would know at index I want something. Firstly, I'm more concerned about finding the stuff that I should find the same value and a same mod value also. So I'll go and find a same value, which is this same value, right? And I also will go and find out the same mod value. So I want the same value, which is p of I. Let's say if it is a prefix, so I'll just go and find the prefix of I. Again, just write down anything whatsoever you have below. Just write it down, because we are finishing up this logic now. So I have this prefix of, again, if you want, I'll do a recap. No worries, because it's a kind of a complex question of maths, just figuring out how to convert those numbers. So I will have a prefix of values, like prefix of this particular value, which I would be needing. Okay, if I have this value, I'll go and find the similar value in the back, right? Okay, that I wanted, one thing which I wanted to just make sure that my counts are equal. Now it is not the only thing. One thing more you wanted, that the length also, which means this condition should also satisfy. This condition, which is the next condition, should also satisfy. Now we converted this condition to this condition L square by 4 mod k, but we wanted that we cannot just do a L square mod k, we want simple L mod k in form. because if we are at index, if we know that we want specific j, if we want some specific j, that specific j will actually be I minus L. Now if I am at I index, I don't know what's the value of L mod k. I know the value of L square mod k, so I wanted to find the value of L mod k. So I just said, rather doing L mod k, I'll modify the modulus value itself. I'll use a k dash in the entire array. So here, instead of doing a mod with k, I am doing a mod with k dash. K dash equals to I mod k dash minus L mod k dash. Now I just get this new k. How I got this new k? By converting and checking if I have a L, if I have a k, and if L square mod k is actually 0. So how my new k should convert, that it should satisfy my existing L. So now we got that, okay, L mod k dash should actually be equal to 0. Now L mod k dash is actually 0. So with this, I know that this L mod k dash is actually 0. So now if I am at index I just have to go and find any index j who has this modulus with k dash as actually 0. So I would want to go and find some same prefix of I. If I am at index I have to go find some same prefix of I and also some same I mod k dash value. I want to find this exact same pair existingly how many times I have seen before. This will give me the count of sub arrays starting from index I having these two conditions are satisfied. Just quickly write down below. Question 1 was count beautiful substrings 1. Constraints was 10 raised to power 3. Okay, got it. I solved with this. Cool. Just quickly write down below that did you get this or not. Again, I will quickly recap the entire stuff. Quickly I will recap the entire stuff. I'll recap with the highlighter. Firstly, for the main condition where we want the vowels in consonant count to be equal, now to get the count to be equal, we just went on and tried to use the prefix sums concept. We went on and tried to use the prefix sums concept. Now in this prefix sums concept, this thing, if we just said, okay, the vowel count will actually be +1, if I encounter vowel, it will be +1. If I encounter a consonant, it will be a -1. With this fact, what will happen is my sub array sum will actually be 0. So I can just simply go and check if I have this value. I can just go and subtract this same value, because you know that the prefix, if I do a prefix of I minus prefix of j minus 1, I will get the sub array sum from I to j. Now if I do a subtraction, and that which means prefix of I minus prefix of j minus 1, in which I have an array from I to j, it is the sum of sub array from I to j. Right? Now I am saying that this sum should be 0 because I have equal number of vowels and consonants. So this part should also be 0. It can only be 0 when both are same. So I know this fact that, okay, both are same, then only it will be 0. With this, I will get to know when the both prefixes are same, I'll go, if I am at this index I, I'll go and look for -1 as the prefix values earlier. But that's not the only condition. I want the other condition also, which is vowel and consonant mod k should actually also be equal to 0. Now I have this condition where v plus c equal to L, because I know that if I am at index j, the length will actually be L. That is ambiguous for us, but right now I know L. I'll just modify this condition vowels and consonants mod k as a new condition of L square mod k. Now you are just ambiguous on which -1 to go to. Can I go to all the -1s? Maybe not. Why? Maybe they would not satisfy this condition of modulus of k. So for that, I figured out that, okay, I want this length to be a modulus of k. So I wanted this length it to be a modulus of k. I wanted this condition to be a modulus of k, right? Which is the L square by 4 mod k should actually be equal to 0. And also I know that my L is actually I minus j also. I know I am at I have to go and find a corresponding j, that's a question mark. So I bought my j on the left side. I have got this condition as new condition for me. Now coming on back to the previous condition which we have, I want to know and find a j if I am standing at this I. So I have to go and eliminate this L. How can I eliminate this L? I can do it if I would know that what is the relationship between L and K. For that, I went on to my entire case. I say, okay, let's imagine that L, I represent that as a prime factor form. It will be P1 raised by E1, P2 raised by E2, P3 raised by E3. K can be P1 raised by K1, P2 raised by K2. Now, I am saying I wanted only L mod something to be actually 0. So I want to convert this K to a K dash, considering I am taking this L as same. So by using this equation, I have to search and find out how I can convert my K to K dash such that I will have a condition with only L. Why I want that? Because I would know that if my L mod K dash is 0, so I'll just do a mod with K dash on this equation. I'll do an equation like this. I know that L mod K dash is equal to 0, so I will know if I'm at index I. If I do a modulus with K dash, I can just go and find for such case whose value, or basically I can just go and find for such J's whose modulus values is actually equal to I mod K dash. I can go and find for all such previous J's. So earlier I was only finding for prefix of i's, but now I'll also find for the I modulus K dash. So to find that K dash value, I just got to know that, okay, E1 should be more than equal to K1 by 2 seal value because of this L by 2 whole square, and I explained very well on why this into 2 got came here, because if it is E1 and it is a square, which is L, it is a P1 raised to the power, if it is a P1 raised to the power E1 whole square, so it is multiplied by P1 raised to the power E1, so it will be P1 raised to the power 2 into E1, so that needs to be greater than equal to P1 raised to the power K1. So for sure your E1 ratio should be greater than equal to K1 raised to the power 2. Now why seal, that also I have explained previously also. But for the case where your base is 2 itself, just make sure that your 2 gets cut, because you imagined your L is E1, so for sure your 2 will get cut, and that's the reason you will just simply get a other condition that your E2, like your E1 should actually be more than equal to K1 by 2 plus 1. With this, you will know that your K should be like this, which means your K1 should be K1 by 2, your K2 should be K2 by 2, and for sure when the base is even, when the prime factor is even, your element should look something like K1 by 2 plus 1. With this, you can find your new K value, which is K dash. Now this K dash will directly satisfy your L, which means your L mod K dash will actually now be equal to 0, because you modified your K to a K dash, you modified your K to a K dash such that it has reduced, so that it can handle your only L. Now with this you can handle, you have got this condition right here. With this you can just modify this condition and get this new condition. With this you will just go and search for, now in the simple prefix sums you only go and search for the first part, but you have two conditions here which for which you have just made a pair of conditions, and now you will go and search for now you will go and search for both of these conditions, and that's how you can simply get this solved. It's just that prefix will work same. K dash you will simply build by seeing the existing K and modifying the values like this. Let's quickly see the code, and again that was not done by me. I took the help from this guy, AWICE. So she has explained it pretty well, but it's like it might be quite hard for you guys to understand. That's the reason we have used it. And yeah, we like his code was a bit like not that great. Well, as it's in Python, it's doing the same stuff, but our code of C++ is a bit more in complexity, because here you see that they can just have a count, but we need to have a map itself. So let's quickly have a look at the code. Again, this was the code which was not written by me, as in like the code was like written by me, but it was originally written by this guy, AWICE. Now again, I showed you he went on and did make the entire prefix array starting from the 0, so right, 0, and then making the prefix array +1 -1 +1 -1. I go on to the I go and want to find my new K. For new K, I will go and find all the prime factors because you know, like in the code I wrote down p I raised to the power some k1. So I'll just go and find, okay, all the prime factors corresponding to that prime factor. What's the count of that prime factor? So it will just say E is saying, okay, what is the count of that prime factor P? As I showed you here also, P1 is the base and E is the count of that prime factor, right? So I just simply go and find if that is modulus by P, which is the prime factor. If it is modulus, your K is being modulus by this, then simply divide it and increase the count of that prime factor. Ultimately, when this loop is over, I would know if for that prime factor P, for that, if that number P is there, for that prime factor P, if its count is actually there or not. Now, if it is there, as I showed you, if your base is itself a 2, you need to modify that to a by 2 value of seal plus 1. If it is not a 2, then simply by 2 with a seal value. So I just said, if it's a base, which means the prime factor is 2, then do a plus 1, else simply do a seal value by 2. Sorry, a by 2 seal value. Now to represent E by 2 seal, other way is E plus 1 by 2. That's another way to solve it. Now with this, you can actually simply say that it is actually a E, your new E, or you can say it is your new K dash K1 new. It is your new K1, right? And then simply you have your P1, you have your new K1, simply you will get your new K dash, right? Or you can just simply write this as a E1 also, E1 new, or you can say it as E2 new. So with this you can get your new K dash, simply P1 raised to the power E1 new. So I just simply say P raised to the power P, which is the current prime factor, raised to the power this new E, which is the new count, which is the new count which I have made, which is this count, right? Again, with this I will get my new K. Now everything is done. The only part was to get this new K. That is the only crux of this question. Then I'll just assign my K to a, so now my K has become the new K. Again, that K has become a new K. Now I'll just simply go and have my simple summation and seeing what is the count of subarrays. It is my answer. I'll go on to my all the prefix values. For the current prefix value, I'll go and find, okay, bro, for this prefix of I, and with I mod K dash, again, it's a K new, right? I mod K, whatsoever is the count, that my number of prefixes I can find, I can add that in my answer. The same I'll go and do for my count and say, okay, that is my P, that's my P, which means I've got the current prefix sums. With this current I mod K dash, simply increase its count that it can be used later on. Same thing as we saw above also, we have a prefix and we have this I mod K dash. If I am at index I, I'll go and look for this particular pair count previously, whatsoever is there. Let's say this count has occurred here. So this count will say me that I can make my sub array from here to here and a sub array from here to here, which means the sub array from here to here and the sub array from here to here. These both sub arrays will satisfy the condition, and that will be both the conditions. This condition will say the count of vowels and consonants are equal. This condition will say that count of vowels and consonants multiplied mod K is actually equal to 0. So that's the reason I have to keep track of a pair of int and int. This first int is the prefix sum, next int is actually a I mod K, and that's how you can simply get this solved. Whew. Why are we doing L by 2? As I showed you, right, our entire length, as I said, our entire length is L from I to J. Entire length includes vowels and consonants, which is actually L. So I'll simply do a vowel plus vowel, because consonants and vowels have become equal because of condition 1. So I'll just simply make them, okay, it's not being erased. Oh yeah, I'll simply make them as equal. So I'll just get my vowel count as L by 2. Now you know that, okay, vowels into consonants, which means vowels and consonants are both equal. So L by 2 into L by 2 mod K should actually be equal to 0. That's the condition which I want to satisfy. That's the reason we are doing a L by 2. Cool. I hope that you guys got it. That was not an easy question. It's a maths a bit tricky question, I should say. Like for sure, not at all easy to grasp it, but yeah, if we just go on and just see it again, we actually get to know it much better. Cool. Any other questions if you guys have, you can just write down below. We will end the stream soon. That was, I should rate this question as more of a 7 because of that logic of maths, because that's not a very easy, although like it might seem at the surface an easy maths, but that's a bit complicated to just figure out how that L/2 is happening and all that stuff. So yeah. Cool. If the folks are still here, can we please smash that like baby to 55 likes? That would be super great, and we will be ending the stream in just a minute. Any doubts, any questions, anything whatsoever you have, just write down that below. We'll be very grateful to answer that. And yeah, for sure, you will see that many other folks have given their approaches. These would not work. Lee has given some approach, maybe it would work. So they have, it's kind of same, I guess. They're finding these values L mod L square by K L1. Yeah, that meanwhile just comment down any of your questions you have. Lee has commented something which seems a bit more easier, but internally it's applying the same logic, as you can see that I'm going on to all of my values of L and trying to figure out the way we were doing to find reverse engineered. He just tried on and did a pre-computation for all those corresponding values. That's also a great part, right? Cool. Maybe if you want, you can, as an extra, you can just go on and look into it, but no worries. We just have to figure out the intuition, the logic, and then the explanation. Cool. If no more questions, then we will be ending the stream right here. Thank you so much for watching. Thank you. Thank you so much for the patience and coming back in. Bye bye, tata, goodbye. That was a big contest. Cool. Thank you, Ashutosh. Thank you, Eklavya. I hope that everything is done. Bye bye, tata, goodbye. Bye. Boom. Pratyush, listen, please, bhai. Arey, bhai, you send your that ID, no, if you want to get it reviewed. We didn't understand the maximum area question of bi-weekly contest. No worries, bro. Go and quickly check that out. Pratyush, just quickly write down your profile name, or just give the link. I have been asking the same stuff since so long. If any one of you wants to get your profile reviewed, just get the link out. Just ask for the link. Cool. We'll be ending the stream. Pratyush, you can just ping your this in the group of ours. And yeah, for the folks who don't know, we have this cute little Insta page opened in which we try to just tell something. This link, which link? This link, भाई साहब ये बंदा अलग ही लेके बैठा है. Cool. Pratyush, you have just 1 minute. Just quickly write down. And yeah, for any other folks, if you have any other doubts, comments, or any other thing, just quickly write down that below. We will quickly go onto it. If not, then thank you so much for watching. I hope that you guys got all the 4 questions. The first one was a bit more tricky than the standard questions. That is quite hard, I should say. The submissions, don't get scared by this. Most of them are wrong. Most of them will get TLE later on. So yeah, no worries on that part. Cool. Bye bye. See ya. Now he has given the link. Oh my god, this guy. Pratyush, this is the ID. Pratyush, copy and just paste this. Just open any of these. Paste it here. Get this. You're doing submissions recently. That's good. That's good. But I can see the frequency is a bit low, considering that you're solving things a lot. Great. That's great. I cannot see the last submissions. I mean, I'm not sure if you're solving it by yourself or you're like, one thing is you are being consistent. That's great. But that's not entirely okay. Like, I think that you are doing great. You should give more virtual contests, I should say. As in the frequency, you will see that okay, it's 1 submissions, 4 submissions. I think it's just a wrong submission, right submissions rather than all the submissions. So I'll say that this you have to increase for sure. You are trying to do more on weekends. I see that on some days, but the frequency has not been consistent enough. So yeah, we can just try to improve the frequency part. That will be much more better. And also, like, I can see you are doing practicing a lot, but you are not improving. You have solved a lot of problems, but you are not improving. And also, you have not given live contest, which means you are still scared of live contest, which in turn means that there can be two stuffs. One is that maybe you don't remember the existing logic which you have done. Like, you're afraid, like, there can be one thing that maybe you're afraid of your rating decrease. That's why you are not giving the contest live, because you have only given the 4 contests. But I can see that you were actually quite regular, so you must be giving with some other ID. That is what I'm thinking right now. So that's one thing. But for the other thing, just try to give more virtual contest, else it will not improve. And try to get things faster. Like, I don't know what's your rank like, or how much time you took for these questions. It looks like that you took 1 hour for this question, which is quite a lot considering for question 2. So for sure it needs practice, but it seems like that, like, I'm not exactly sure, but it seems like you have not solved all the question by yourself. Maybe you have just got the approach. You thought that you have got the approach, and then you have just said, okay, I'll just solve it. It is easily solvable. So that is one thing. Okay, we have a few more. Let's see. Is system design required for freshers? How to improve in contest? No, bhai, is its same ID. But if you have given just 4 contests, then for sure you need to give more contest. You are not giving contest. You should give contest sincerely. That's one thing I would say, if this is your main ID itself. Because for me also, sometimes when I feel like I'm very late, I just skip contests and maybe try to give with some other ID. But yeah, oh yeah, Sukhpreet has been constant a lot, and that's quite amazing, I'll say. Oh, my battery is dead. Wow, my battery is dead. I'll have this filter. Okay, this camera, I think it's visible now. Yeah, work screen, circle filter. Oh, circle filter, I should get this and this as down. It's visible kind of roughly, or I should, okay, cool. It's something right now, like, we'll end the stream. It has been a bit long, but yeah, we'll quickly see a bit more. Just have this good thing that Sukhpreet has been much more regular. That's great for Sukhpreet. And also he has been improving. That's also super great. And he has been giving a lot of contests, attended a 31 contest. So yeah, that is what I want in a profile. Your number of contests attended should actually be large. You should be consistent, and you should be absolving. If I go back and see for yesterday's contest questions, it's a maximum area of the hole in the grid. maximum coins of fruits for this. Find the containers. Sum of, I think there was question number 4, which was find maximum non-decreasing length. He has done 3 questions, but Supreet, like considering that you have watched like yesterday's live stream, so yeah, it was yesterday like live stream, so I might not expect to solve that question by now because you might have slept yesterday, but still do solve that question because you have not solved that question, I guess. Minimum number of coins of fruits. Oh, like you find maximum non-decreasing. Find maximum non-decreasing. Oh yeah, cannot absolve it. So yeah, absolving I'll say, because you are at a good point that you should absolve question 4 for sure. So yeah, absolve that question 4 for sure. And yeah, as Pratyush is saying, can you please help me? Yeah, like you guys can come to the Telegram group and help each other out, and others also in the community, that they can actually get benefited and also get things done. Cool. Oh, like we have connections already. Oh, we have connected. That's great. Cool. Like we'll go on to the next one. We'll end the stream soon. Yes, I'll upload it, absolve it today. That's great. That's great. We have Eklavya PC. Let's see. Cool. Firstly, contest attended. It's great. That is what I want. Again, he has been increasing. That's super great. That's best thing. And you have been solving it. Oh, NIT Rawat, great. And you have been solving also regularly. That is what I want in a profile. More contest, solving problems, and trying your level best. Until unless if I solve you, if I see a profile having a less contest being given or not solving regularly, I'll say that okay, for sure it's expected that you are not progressing by yourself. So give contest, and that too faithfully, on time, with full concentration, sitting down. Okay, I should look here because my camera is dead, and I can see that he also has been doing well. Yeah, just absolve it, and that will be much great. So that's nice. See, I just like this part itself. So I just like this part itself, that you guys should actually absolve. Cool. Let's go on to next one. King Slayer. Oof. Naam to dekho, King Slayer. We'll end the stream soon though, because it's a time. 65 contest. That is great. Ankur. That's great. Like you can see that this guy has solved 1,123 problems. This is actually great. So that is the things which we required. Ankur Kumar, hats off, man. Hats off. Great. Cool. See, like you guys are doing already good. That is what I was saying. Okay, where's that gone? Like that is already good. See, bit more, like bit depth could actually go 3, 4, 2, 3. That you can see. Also, he also got a 2 out of 4 from solve. That's very normal. That's very normal. So that is very normal for you. So that is very, very, very normal, that it can be, see, like you can look that he has been going pretty well, and then he got just solved 2 problems in these 2 contests, and see 4, 2. So that can be a chance. Even if you are solving 4 problems, it also happens with me. Even if I solve 4 problems, there are cases when I solve just 2 problems. So no worries to just get demotivated that I was only able to solve 2 problems. Just absolve it. And yeah, if the folks are watching it, can you please smash that like button to exercise for more. That was super great. Cool. Any other left? Okay, bye. That's it. Kingslayer, that's great. Ankur Kumar, that's great. Supreet, cool. Kingslayer, I will also do. Cool. That's it. Thank you so much for watching. Bye bye. See you guys. Goodbye. Thank you so much for turning back in. We will see you in the next week in the next live stream. Bye bye. Tata. Goodbye. See you. Tada. Yeah, before going, can you please smash it 55? Just one more. That was super great. Cool. Let's end it, and bye bye.